Okay, so a very good morning to all. We have started with the constructional aspects of the energy efficient motors yesterday. So we will quickly do a recap of last lecture and we will start with the further topics related to the energy conservation in the motor. So yesterday we have seen that how an energy efficient motor is um, different from the standard motor with respect to the constructional aspects. So we have seen that energy efficient motors differ from the standard motor. There are a few positive features when we compared this energy efficient motors with the standard motors. The first one is the energy efficient motor have higher quality low loss laminations for the magnetic circuit. They are more and better quality copper in the windings, then better quality insulation, then optimized air gap between the rotor and the stator, reduced fan losses, and closer matching tolerances. These are some of the positive features of the energy efficient motor as compared with the standard motor. One more point which we have seen yesterday is the greater core length. So, because of all these features, just a minute. Functional features, the energy efficient motors uh, they actually have the better capability of energy conservation in case of the energy efficient motors as compared to the standard motors. So we have also seen two videos related to the energy efficient motors. How does energy efficient motor of the motors for the various applications? Because we know that if we talk about the industry, the majority of the components are the motors. So the selection of the motor plays a major role. How the rating of the motor should be selected for the particular applications that we have seen yesterday with the help of a video. Uh, Today we will see few more related to this motors, that how these motors we should follow a good maintenance practice for the proper motor operations, because as we know that motors are uh, the major components which are present in an industry. So it's very important that the motor should have good maintenance, so that there is a proper motor operations and the productivity of the site can be increased. So these are few points which are to be taken into consideration when we So one by one, we will see. The first point is inspecting motors regularly for wear in bearings and housings to reduce frictional losses, and for dirt, dust in motor ventilating ducts to ensure the proper heat dissipation. Yesterday, we have seen two videos. In that one of the video, you have uh, noticed that the site conditions also plays a major role for the selection of the motor. Like if the site is in a desert place, if the site is nearby to the sea, then accordingly we have to place the motor in a proper position, so that the regular operations of the motor will not hamper because of the site considerations. So, as a good maintenance practice, if we inspect the motors regularly for the wear in bearings, and housings to reduce the frictional losses, because in the last lecture we have also seen that the efficiency of the motor plays a major role, and efficiency is nothing but the ratio of the mechanical energy delivered at the rotating shaft to the electrical energy input at its terminals. So if we talk about the frictional losses, if we can reduce the frictional losses, then the efficiency of the motor can be increased considerably. So this can be done by regular inspection of the motors for wear in bearings and the housings. Also for the dust in the motor ventilating ducts to ensure the proper heat dissipation. So we have we have seen here that there is a reduced fan losses in case of the energy efficient motors, and we have also seen that we should appropriately place the energy efficient motor uh, with respect to the applications. Like these are some of the places where the economically it would be economically bad if we employ an energy efficient motors in hoist and cranes, traction drives, punch presses, machine tools, centrifuges. This we have seen yesterday. So the first point with respect to the good maintenance practice for proper motor operation is to inspect the motors regularly for wear in bearings and housings to reduce the frictional losses, and for dirt dust in motor ventilating duct, to ensure the proper heat dissipation. Next is checking load conditions to ensure that the motor is not over or underloaded. This is also very important. We should we should have a monitoring of the loading conditions, that what is the loading conditions of the motor. Um, Whether the motor is underloaded or overloaded, this we have to ensure, because both the cases are dangerous for us. Because if the motor is underloaded, then also there will be an effect in the efficiency of the motor. Similarly, if the motor is underloaded, then also there will be an effect in the efficiency of the motor. At the same time, we have to change in motor load from last test indicates a change in the driven load, the cause of which should be understood. So the skilled personnels who are employed in the shop floor, who are actually working on the motor, they should monitor the change in the motor load from the last test, which whenever it is done, and they should make the proper cause of which should be understood. That is, they should know that why there is a change in load, and if at all they can reduce these changes, that would be better. Sometimes we have also come across the term called variable speed drives. In the sixth semester, you might have learned this: variable frequency drives, variable speed drives. So nowadays, these are employed in large number in the industries, because this gives us flexibility in terms of the RPMs. That is, sometimes some load will require different RPM rating than the other. If we employ the fixed in terms of the because of that, and that's why it's feasible or it's advisable to employ this particular applications. Then lubricating appropriately, this is also important. If all these motors are heavy duty motors, and because all these motors they are working round the clock, 24 hours they are working. The work is continued in shift in the industries, so continuously these motors are performing their duties. So that's why lubricating the motors appropriately is also one of the consideration that will help us for the energy conservation in the motors. Next is checking periodically for proper alignment of motors and the driven equipments. So, if there is an improper alignment, then it can cause the bearings to wear quickly. So, the bearings of the motors they may wear quickly, which may result in damage to both the motor and the driven equipment. So, like if we take the case of say paper mill or textile mills, there are large number of driven equipments which are driven by the motors. So there should be a proper check of the uh, alignment, that whether the alignment between the motor and the driven equipment is proper or not. If the alignment is not proper, then the bearings of the motor can get in damage, and we may have to replace the bearing, which may incur additional investment in the system, and ultimately which may affect the production as well as the per unit cost of the manufactured unit. So that's why it's better to have a proper alignment between the motor and the driven equipment. Next is ensuring that supply wiring and terminal box are properly sized and installed. Inspect regularly the connections at the motor and starter to be sure that they are clean and tight. So this is also one of the important thing, that we should always ensure that the supply wiring and the terminal box they are properly sized. If they are improperly sized, then we have to size them properly, because the input current is the major criteria for the parameters or the attributes which help us to improve the overall efficiency of the system. Like we have already seen, these are the two parameters that attribute to the efficiency of the electricity used by the AC induction motors, and these are the motors which are in large number in the industries. So the AC induction motors are in large number in any type of industry, and if we are not employing proper wiring or terminal box, or it is not sized, then this may create issues in the input current to the motor. And if the input current drawn by the motor is large, then you can just imagine that there will be increase in the intake current, and it may increase the consumption of the electricity in that particular plant. That's why we have to ensure the wiring and the terminal box are properly sized and installed. Inspect regularly and connect the connections at the motor and starter to be sure that they are clean and tight. So these are some of the checklist of the good maintenance practices for the proper motor operations. Next, the effect of harmonics on the motor operations. I hope you all so. Harmonics is basically the multiples of the fundamental frequency. So the whenever there are harmonics like third order harmonics, fifth order harmonics, then because of this harmonics there is a distortion in the waveform. uh, Generally we know that we should have a sinusoidal waveform, because the AC generation is having the, just a minute. So, the sinusoidal waveform is expected at the supply side as well as the load side. So, if there is a distortion in the waveform, then there arises the effect of the harmonics. So let us see what are the effect of harmonics on the motor operations. So harmonics increase the motor losses. So if there is if the harmonics increases in the motor operation, then the losses in the motor will increase. And if the losses will increase, you all know that there will be an overall effect in the efficiency of the motor. So that's why the effect of harmonics on the motor is also important parameter which should be known, and there should be sufficient mitigation to this elimination of this harmonics on the motor terminals. So the non-sinusoidal supply results in harmonic total current drawn. So if the total current drawn will increase, energy will increase, and if the consumption of the electrical energy, understand that what will be the overall effect from the system. Next is the rotor resistance, or more precisely impedance, increases significantly at harmonic frequencies, leading to less efficient operation. So every time we are talking about the increase in the productivity, then increased competitiveness, etc. And this can be only achieved when the per unit cost of production is reduced. And energy plays a significant role, or energy is one of the most important parameter in the per unit cost of the production of any product. So if the energy cost is increasing, that means the overall cost of the per unit production, that will also increase. So that's why it is not advisable to have more losses in the motor side, because if there is more losses, then the current drawn will be more, and if the current drawn will be more, then the per unit cost of generation of the particular product which the manufacturer is manufacturing will also increase. And because of all these things, what will happen, the product will lose the competitiveness in the market. That's why all these technical parameters are very important in any industry. Next point is stray load losses can increase significantly at harmonic frequencies. And overall motor losses increase by about 20% with a 6-step voltage waveform compared to. So this all checklists we have to note it down, because improving all these things will ultimately result in the better efficiency of the system and the better productivity of that particular site. Harmonics can also contribute to low power factor. So in the previous lectures, we have already seen that how low power factor contributes to the increase in the demand charges, and how the increase in the demand charges will affect the overall electricity bill of that particular consumer. This we have already seen in the previous lectures. So I will not go into detail right now. So you have to just remember that harmonics can also contribute to the low power factor. That's why the mitigation of this harmonics, or minimize the effect of the harmonics on the motor operations, is very much essential if we want to achieve the energy conservation in the motor side. So these were some of the points which were related to the harmonics effect of harmonics on the motor operation. So I hope you all have noted how to complete our unit number 5. Um, we will watch a video right now related to the maintenance side. As we have gone through this, we will. Just a minute.
With any industrial process, it is important to properly maintain your equipment. Proper maintenance maximizes the availability of the machine, reduces breakdowns, and protects your investment by ensuring a long and productive life cycle. Proper maintenance also ensures the safety of operating personnel and helps protect the environment. In order to successfully manage maintenance operations, it is best to organize the frequency and type of maintenance according to a program or strategy. There are three basic maintenance strategies: reactive, preventive, and predictive. With a reactive strategy, maintenance is only performed when equipment breaks down. Although not suitable for most processes, it can be acceptable in situations where process downtime isn't a major concern, such as non-critical applications, or where redundancy or spare capacity exists. Reactive maintenance is also acceptable for processes where maintenance personnel and spare parts are readily available, ensuring that repairs are performed quickly and outages are kept short.
So right now we are viewing the maintenance strategies. So maintenance, basically there are of two types. One is the preventive maintenance and the second is the corrective maintenance. Preventive maintenance is the type of maintenance which is done on a regular basis in the plant, so that they are, all the machineries which are installed in the plant, they work properly without any breakdowns. So preventive maintenance strategies, like if the strategy of the plant is to have the maintenance after every 6 months, so they will shut down all the equipments, they will do the preventive maintenance, and again they will start the production. So this is the strategy of the preventive maintenance. Second one is the corrective maintenance. Corrective maintenance is the type of maintenance wherein the machineries or the installed system are corrected when there is a breakdown due to any failure, any type of failure in the system.
Preventive maintenance, on the other hand, seeks to maximize equipment availability to avoid costly production stops. Consumable parts are changed regularly and machines inspected to spot issues before they become serious. The preventive actions are performed according to planned schedules, based on the manufacturer's unique knowledge of components' expected lifetime and organized into planned operation stops. If maintenance is managed correctly, the process is more likely to run without interruption until the next scheduled outage. The predictive maintenance strategy uses the actual condition of the equipment to determine both what needs to be maintained and when it needs to be done. The condition of various machine components is assessed by different on- and offline measurements. This data is used to plan proper condition-based maintenance, ensuring that maintenance is performed only when necessary, thus minimizing. Each strategy has advantages and disadvantages, so detailed knowledge of the needs of the process, its operation, and the criticality of its component machines is vital for determining the right strategy. ABB offers help to determine the most appropriate maintenance strategy. Quite often, this will be a mix of different strategies tailored to the requirements of the process. In the end, the best strategy will be the one that offers the lowest cost of ownership by minimizing the cost of not running, as we saw in a previous module.
So the maintenance plays a major role, and whatever is the make of the motors which the system is running, like we have watched a video which is prepared by ABB, and ABB is a pioneer in the drive system, and there are many plants which are running the drives which is actually manufactured by ABB. So the ABB is the OEM, that is original equipment manufacturer for all such types of drives, and there is a particular strategy which is planned for the ownership of all by minimizing the cost of not running. So not running means if the system is down, like if there is a breakdown in the system because of the failure of any component in the system, then it would cost the it would cost a lot of money to the industries, because not running the system will make the system hampered, and their product will not be manufactured, and there will be less competitiveness of that particular customer. So that's why these all strategies are very important nowadays. Actually, the downtime of the system is reduced. We will see one more video.
In the previous module, we looked at the three main maintenance strategies in use today. Maintenance. Over the next two modules, we will look more closely at the predictive maintenance strategy and what it means for users of low and medium voltage motors and generators. The predictive maintenance strategy uses the actual condition of the equipment to plan what maintenance needs to be performed and when it should be carried out. Various machine components are monitored by different on- and offline measurements. As these measurements are used to assess the condition of the motor, the process is called condition monitoring. In an earlier module, we looked at the different factors that can affect a motor's performance, leading to a maintenance requirement. Many of those can be measured as part of a condition monitoring program, but the most common ones concern the power.
So this is the case study which we are understanding in which is done by the ABB, which is the condition monitoring. They are doing the both the part, that is online as well as the offline monitoring.
What needs to be measured and whether the readings are taken on or offline is highly dependent on the size and power of the motor being monitored, and it is here that the differences between low and high powered motors become more apparent. With lower power motors, the failures tend to be due to issues with the bearings. Whereas with high power motors, the problems tend to lie more in the stator windings and rotor bars, the parts of the motor.
So here you can see that condition monitoring is done for the low power motors and the high power motors, and based on the condition monitoring, what the conclusion is made is that the parts of the motor which are under the most stress, both the electrical and mechanical, are distributed in percentages. Like in low power motors, 57.4% are in bearings, 24.2% is in other issues, and 18.4% is in the stator windings. Similarly, in high power motors, it is different. So in high power motors, stator windings are about 60.5%, 18.4% is in the bearings, and 21.1% is the other issues. So this is a case study which we are going through, that if we are doing a conditional monitoring of the motors, this condition monitoring is done both by online and offline data. As you all are right now aware that in online system we have the latest technologies available with us, which is called as IoT technologies, right? Internet of Things. So what we do is all this motor is connected through the online monitoring system. Like all the parameters which are required to be monitored, those are monitored in the online form so that the timely decisions can be taken, and due to the timely decisions the downtime can be minimized.
Under the most stress, both electrical and mechanical. The condition of these internal active parts usually require direct inspection and measurement, so inspections are performed offline, in addition to the online measurements taken while the machine is running. We'll take a deeper look into the on and offline measurements used for condition monitoring high power motors in the next module. In contrast, the windings in low power, low voltage motors are under less electromechanical stress and rarely need internal inspection. This means that the condition can usually be adequately assessed using online monitoring only. To simplify online condition monitoring of low voltage motors, ABB provides an all-in-one solution called ABB Ability Smart Sensor for Motors.
So we are understanding the case study of the ABB, where they are using the smart sensors for the motor so that the data can be gathered continuously and the timely decisions can be taken for all these motors. Let us have a look.
Attached to the side of the motor, the sensor unit monitors signals from the motor and transfers the data to a secure server in the cloud. The server then analyzes the data to produce diagnostic information and performance alerts that can be sent directly to the user's smart device. A simple traffic light display gives a quick overview of the motor's condition, allowing necessary maintenance to be planned and executed before the motor's condition worsens and causes an unplanned production stop. Knowing this information,
so before actually there is a breakdown or there is an effect on the production, the decisions can be taken timely with the help of these smart sensors.
allows maintenance resources to be deployed more efficiently, which in turn improves performance and extends the lifetime of the motor. By minimizing outages caused by failed motors, plant productivity and profitability can also increase. In the next module, we will look at the on and offline measurements used in condition monitoring for high.
So these are the points which we have to note. With the help of a case study of ABB, we have come to know that there are various terminologies which are used in this particular segment, and if we can inculcate all these things in our industries, then it will be easy for us to note all these points and to have a better energy conservation opportunities in the motors. Now let us move on to the next part, that is the energy conservation in fans. There are two topics related to this. One is in fans and other is in the pumps, and we will end up with our unit number 5. So saving opportunities in the fan applications. So by using all these points, we will be able to achieve an energy saving opportunities in the fan applications. Let us see one by one. Change in impeller by high efficiency impeller along with cone. So you all have studied the induced fan, rod fan, which are used in the power plants to inject the air for the combustion, right? In the sixth semester of power station practice, you all have learned the use of the induced and the rod fan. So there you can increase the energy savings in this particular induced and draft fan by the change of impeller by a high efficiency impeller along with cone. So this will help for the savings in the energy which will be utilized in that particular fan. Next is change of fan assembly as a whole by a high efficiency fan. So we all know that